Hi everyone, welcome back. Today we will be discussing a problem known as double spending problem. This is a problem I have asked in many of my interviews and the candidates are not able to answer what a double spending problem is and how to fix it. So I thought of making a video on it. So we will be discussing the issue of double spending problem and then how to fix it. Let us read the first bullet point. Due to delay in a distributed system, and client retries. Payment can be made more than once. We will come to the payment part, but consider a very simple scenario of splitwise. Suppose your phone is running low on resources, maybe on CPU or memory, and due to that, the splitwise app is hanging. You are trying to create a group, and since the UI is freezing, you click on the create group button multiple times. Let's say one time, two times, three times. Should it create only one group or should it create three groups? The answer to that is it should know that it has to create only one group. Even though multiple requests are coming since you press the UI button, the button on the UI multiple times, it should only create the group once. How does it know that? This is a very simple scenario to understand and appreciate the double spending problem. Now let us come to the payments part. Suppose you are making a payment and due to, let's say, any network glitch, once the payment is done from your side and the amount is deducted and the response to the server is coming that the payment has been done, and let's say there is a network glitch due to which the server is not able to receive any kind of response from the payment gateway if the debit has been done or not. Let's say it wait for 2 minutes, 5 minutes, and then it decides that okay, the payment is not done and it fails. In the meanwhile, you click on the UI to pay again for the same kind of transaction. Same transaction, you click on the UI again to pay. Should it deduct the amount twice? In the meanwhile, the server is also having a retry loop where, let's say, after 1 minute, it will again poll the payment gateway to know if the payment was successful or not. And let's say after two attempts, it came to know the network glitch went away and it came to know that okay, the payment has been done. Now the payment has been done and you clicked on the pay button again. The server should not deduct any more amount because you have already paid for this. And this is the concept of double spending problem, where for a given transaction, you should not be charged more than once. This is a very simplified explanation of what a double spending problem is. Now, how to fix this issue? To cope this problem, we implement something known as idempotency. Now let us come to the concept of idempotency. Basically, what we want is even though we send multiple requests, we want that the effect should take place only once. You are clicking on the button for creation of the group in splitwise many more times, but it should create the group only once. Let's say you are creating flatmate groups, right? Or let's say some Jaipur outing group, right? So let's read. An idempotent method can be called multiple times. Yes, it can be called multiple times, just like we are sending the request multiple times by clicking on the UI. Or here, the retry loop in the server and the button you are pressing on the UI are basically trying to deduct the amount both at the same time. With the same parameters, and the side effect will be the same as making a single request. Even though you are executing call multiple times, but it should be like you have executed the call only once. The net effect should be like that. This does not mean the response has to be the same each time, but the state of the resource on the server will end up the same. What does this mean? Consider delete method. And let's say there exists some resource with ID 101. The first time you execute the delete request, this resource corresponding to this ID will be deleted. And you will be getting, let's say, a response that means 200. Okay. The next time you execute delete, now there is no resource here. Let's say you get 204, which basically means that no content. Because the resource has already been deleted in the previous request, right? So a delete in the first call may return a 200 OK. And now in the subsequent calls with the same parameters can respond with 204, which means no content. Here the response differ. Once you are getting 200 and after every subsequent call for this ID 101, you are getting 204. So the responses differ, but the state of the resource on server will end up the same. Let's say after the execution of the first request, there were 99 resources on the server. Now, after you started executing the same delete request again and again, let's say 2 times, 3 times, there will be 99 resources only because the resource for this ID has already been deleted. So the state of the resource on servers will end up the same no matter how many times this delete call is executed. Clients can repeat idempotent requests without worrying about causing unintended changes. That's right. Classic examples are get, head, put, and delete. Why get and head? They are just requests which are not intended to modify the server resources, correct? They just fetch the data. So they are by default idempotent. What about delete? We just saw that delete is also idempotent because of the reasons we just discussed here. What about put? A put request is nothing where we provide the whole resource. So let's say I want to change, for this ID the name was Gaurav with small g, and I want to change it to capital Gaurav. I will provide the whole payload, the name, the age, the gender, and this will put the data on the server, basically replacing the entire resource with whatever I have put in the puts request body. So that's why put is also also an idempotent method. How is it implemented? We talked about what a double spending problem is, then what how it is implemented. For that we discussed the idempotency. But now how do we implement the idempotency? So idempotency is nothing. See, here the concept is very easy. Here you know that I have to delete a resource by its ID. ID is nothing but a primary key. Each resource will have a unique ID, right? So when you click on delete request, when you execute the delete request multiple times for the same ID, the server knows that this ID has already been deleted. So no resource change on the server side, no state change. So basically the implementation uses a concept called idempotency keys. This idempotency key is nothing but a similar to the ID we discussed in the delete example. For a request and its retries, idempotency key is unique identifier, right? Because this ID is a primary key for a record and primary key is also a unique identifier. For example, a UUID. UUID is um, a universally unique identifier, which is a way to generate IDs. Example, in case of payments, we can use transaction ID as idempotency key. Anything which is basically able to uniquely identify a resource. It can be a primary key, let's say the student ID, or it can be the transaction ID in case of payments, like that. Now on the client side, generate idempotency key and include it in the request headers or payload. On the server side, once client generates this ID or the idempotency key and sends it in the request to the server, server store the key along with the operations outcome. If the same key is received, again return the stored response without re-executing the operation. So if the same key is passed again in the request, then server does nothing but returns the same response which it had provided before. In the above example, it did not return the same response. First time it returned 200, next time it returned 204. But the idea is that on the server side, no other side effect took place. Now let us consider some example. I executed the put request on this endpoint slash users slash Gaurav Kabra. I passed the idempotency key. This is, let's say, some kind of UUID, which I passed along with the request. And this is the payload, the request I'm passing that, okay, for this endpoint, this resource, I want the email as gauravkabra.official@gmail.com. Since put is idempotent, we discussed, right? Here we discussed that put is idempotent because we pass the entire resource in each request. The server processes the request, but only the first request changes Gaurav's email. All subsequent requests find that the Gaurav's email already matches the desired state and therefore make no changes. If they are retries, same idempotency key is sent and hence no changes take place on server side. Like in the payments we discussed, that we will be sending a payment ID or maybe a transaction ID. So basically, if they are retries, same idempotency key is being sent, which is transaction ID, and hence no changes take place on the server side. Server skips the execution basically and returns an appropriate response to the client. Now, generally idempotency keys have an expiry. For example, a transaction is valid for, let's say, 15 minutes. For 15 minutes, the server can keep retrying, let's say 3 times after every 5 minutes, after which it assumes that the transaction has failed and then idempotency key is expired. That means there is no sense of storing the idempotency key any longer after 15 minutes, so we expire it, we dump it. Long enough to cover the retry window. Just like for 15 minutes, let's say 3 retries, but not indefinite to avoid unbounded growth of stored data. We do not store this data for uh, uh, basically permanent purpose. It is an ephemeral data for, let's say, 15 minutes we store this. Now, idempotency is one concept. The next concept is the safety part. What are safe methods? Safe methods are only read-only methods. For example, get and head. They do not change anything on the server no matter you call them first time or the second time or nth time. They are just read method which just fetch the data. Correct? So they are inherently idempotent because they are just retrieving the data, reading the data. So what is the difference between idempotency and safety? Safe methods guarantee no side effect, while idempotent methods allow for side effects but ensure that repeated retries do not introduce additional changes after the first operation. The last concept is put versus patch. We have spent enough time understanding why put is an idempotent method. But what about patch? Generally, put has the whole resource in each request. And patch, as the name suggests, just patches. So it carries whatever you want to change. That means the diff that you want to change. For example, you executed that for this person, increment the bank balance account from 100 rupees to, let's say, you send the delta to plus 10. So the bank balance account in the first request, first patch request will be 110. When you send the second patch request, you again send the same delta, but this time the bank balance is 110. So it will lead to 120 because you are changing it by plus 10. So it is 120, correct? So this is the concept of patch. And since in each request, the server side resource state is different, that's why it is not an idempotent method. So let's read. Patch carries a diff, correct? rather than full replacement of the resource. Input, we send the full replacement every time. So applying those instructions multiple times may produce different outcomes. Why I'm saying may? Because let's say um, I just want to patch the name. So the first request I sent Gaurav. The second request also I sent Gaurav. So net effect is there is no change in the resource, correct? So it may or may not change, but in most sanity scenarios, we send patch request for the increment, decrement, or any delta scenarios. And that's how we say that it produces different outcomes. Put replaces the entire resource, and thus when repeated always yields the same end state. Patch is stateful. Example, increment a counter by 1, leading to non-idempotent behavior. By stateful, I mean here that the server state matters each time. So the first time you send, the state was 100 rupees. The second time you send a patch request, it was 110 rupees. So the state is different. That means it is concerned with the state, and hence I am mentioning it as stateful. But patch request can be issued in such a way to be idempotent. How we can make a patch request as idempotent? By default, patch requests are not idempotent. So if someone asks you if patch is an idempotent method or not, then you say that by default no, but we can make it idempotent. How? By carefully designing the patch format and using conditional requests. For example, some entity tags are there. What are entity tags? Entity tags are, you can consider as a simply that entity tags help us identify resources uniquely. So let's say there was a resource R1 with some version 1. Let's say you first time you create it, it is version 1. So corresponding to that, some e tag ID was there, which is 1. Now you change it. Let's say you change the name inside the resource, so it is effectively version 2. The e tag will change automatically. So this way you know that since previous the e tag was 1 and now it is 2, that means some resource, some this state of this resource has been changed. So this is, you can consider at a high level just like hash values changes when you change the object, correct? So e tag with if match or if unmodified, since we will come to this, to guard against unintended repetition. Also can design patches to replace or upset values rather than increment or appending. This replacement or upset we already discussed. I mentioned here that the first time I am calling patch, I am sending name as Gaurav, and second time also I am sending name as Gaurav only. So it is basically replacing, not incrementing, right? It is not incrementing, rather patching, right? Now let's come to what is this if match or if unmodified since. These are entity tags or e tags. So let's say I say that if match version 1, then only update, else return. So let's say I two threads are there. Let's say thread 1 and thread 2. We are not talking in terms of operating system. Just I am mentioning as thread 1 and thread 2 to basically signify two requests are coming in parallel, and they will be executed concurrently. So thread 1 changes the resource. Let's say it changes the name from Gaurav to small Gaurav. And due to this, the version, the e tag changes automatically to, let's say, V2. You see, we discussed here, right? Version text, this e tag changes kind of a version vector. Now, when T2 comes, it will try to change the name from Gaurav to something else. But the condition is if matches version 1, then only update. Now the version is V2 since T1 has executed. Since T1 has executed, version has changed V2, which is not equal to V1. So if match V1 is false condition, so it enters else block and it will immediately return. So this is how, using these tags, e tags if match and if unmodified, since it is concerned with timestamp, date time. These e tags can be used to make patch calls idempotent. And yeah, this is the whole concept of idempotency. So in this video, we discussed what a double spending problem is, the concept of idempotency, the general implementation, how it is implemented, and how it is different from safety, put versus patch, and how to make patch an idempotent method. Thank you.